So we are on lesson 2 of unit 6. And granted, there's like a couple add-in lessons with this unit too. So really, if you just go by Schoology, I sort the units by color. All right, so everything from the blue folders is over and done with, except for like per the syllabus, you can come and retake a unit test or do corrections on it. I actually prefer corrections because you can't do worse. So you can do that up until the next unit test. And I'm telling you now, the next unit test is going to be before you leave for spring break. Okay, so if you are wanting to get your grade up on that, grades are still going in shortly, so I have to hand grade a lot of stuff. So that's gonna probably take me today and tomorrow, but it's going in. So you'll know that that's your true score when you see the little comment that says retake given in class, higher of 2 scores given. And then if you still want to like come back and do corrections, you can do that in tutoring and stuff. And of course, there's other things too. I still need to adjust after that, like those lower quiz scores. I'll bump them to your match your unit test score. Some people got extra credit from that Kahoot for winning and all that stuff I need to add still. I have not forgotten. I've just been great. So leave me alone. Just kidding. But like seriously, like I'm working hard on getting those grades updated since those are worth more of your grades than like you're missing homework from days ago. All right. So here's the goal for today. Let's describe some patterns of change. We've kind of been doing that a lot in every single unit. So we're looking at a new different kind of pattern. And we've previously talked about some of these. We need to be able to tell whether a pattern is growing linearly, exponentially, or quadratically. So at least 2 of these you should be very familiar with. One of them we just barely learned yesterday. So like linearly, how does that graph look? Linear, so like, give me something else that doesn't use the word linear. Because that's like saying, okay, great, thank you. I can't think of an analogy, but like, I don't know, saying it looks linear, well, great. I got that from the word, but like, give me more. So yeah, a straight line. And if it's growing, it would look like that from left to right. Exponentially would look like what?
Round.
It would have kind of a curve to it. So if it's exponential growth, it starts around the same and then grows at a really fast rate. What do the quadratics look like? They look like U shapes. So they either look like this, which is probably what it means if it's growing, or they might look like that. All right, and we learned the 2 equations for linear and exponential. What's the equation for linear? Okay, good. What about for exponential? Perfect. I have not yet taught you the equation for quadratics, but by the end of this lesson, you should be able to tell me it. And that's how you'll know that you're successful if you can meet all the learning targets. That's why they're even in there to begin with. Use them kind of like a study guide. So last thing, you'll know an expression with a square term is called a quadratic. So I'm recording right now. Puzzle piece for this will be lesson 2. And we were supposed to have a quiz today after lesson 2, and we certainly do have time to. But I decided to be nice and give you like the rest of today to study. And then we're taking it for sure tomorrow. So quiz that's over lesson 1 and 2. So make sure especially that those practices are done and that you understand them, because those are what we base the quizzes off of. And you should have time to work on it today unless you guys get too rowdy and the lesson takes too long. Henry? Yes. If you miss points on your binder check, I actually put a comment in the gradebook that has the deadline for when you turn that in. Okay, so any other questions? All right, so then moving on. All right, the warm up that I gave you time to work on, so we're just gonna jump right into it. Last time, whoever was the reporter that ended last class, we'll pick the reporter to start with today. So whoever ended with yesterday can pick today the reporter. If they're absent, like rock, paper, scissors, they're really tight. So table 1, can you explain to me how they got 6 times 8 minus 2 times 3? Like, where would they get the 6 from?
The left side, then the 8's on the bottom, 2 is on the top left, the top right.
Okay, let's slow down there. We got 6 on the left, 8 on the bottom, you said, so 4, 5, 6, 7, 8. And kind of like how yesterday we worked with area, if I wanted to find this whole area, what could I equally do?
6 times 8 minus 8.
Well, 6 times 8, yes, 48. But is that how many boxes there are?
No.
No, they're basically basing it off of if this was filled. So then, John, can you re-explain the 2 times 3? Okay, so these 2, and then, or wait, did I miss it up? Oh, wait, no, okay. Let me put it this way. 2 by 1, 2, 3. So it's like if these were filled, that would be like a 2 by 3 box, which gives me how many squares? 5. And then why do we subtract them?
Because they're missing.
Because they're missing. So then we get a total of how many squares? Okay, good. Table 3, can you explain to me how expression B represents it?
Yeah. 4 on the far right. And the 8 at the bottom.
Okay. So that gives me the area of this rectangle, right? But not the whole thing. What's 4 times 8 class? 32. And then the 2 times 5, table 3, can you explain that part?
Just the part that's not in that, the 2 on the one side.
Can we chill out with all the tapping and stuff? Multiple people. Okay. Yes, the 2 by 5 gives me a total of what? And then combine them, that'll give us the total area of the whole thing, which is, okay, good. These are really great prep for your state testing. They love to put these types of questions, like areas of weird shapes, on your state testing. So it's good that this is what we're starting with. Table 5. Can you explain to me expression C? Okay, so they're counting each row. There's 4 rows of 8, so 8 plus 8 plus 8, and then where are they getting the 5? All right, adding them all together gives us a total of 42. And if you remember, multiplication is repeated addition, right? So that's why some of these are written differently. This one is kind of like a more expanded version of B, right? You could do 4 times 8. That's the same as doing 8 plus 8 plus 8 plus 8 and all that stuff. Table 7, expression D. Can you explain that one to me?
5 times 6 plus 3.
Okay, where are they getting the 5 times 6 from? 1, 2, 3, 4, 5. The 6 from? Okay, 3, 4, 5, 6. So that gives us the area of this rectangle, which is what, class? And then the area of this one would be 12, because it's the 3 squares by the 4 squares, the 3 times 4. Add them together, we get our total area. So questions about that? All right, so that's kind of like what we were doing yesterday, except now you can see the square units. That's why we call area like unit squared. Scrolling down. So now we have other patterns. Study the 2 patterns with your groups. Talk about how the number of dots is changing in each pattern. And then figure out what number of dots would be in step 5. So that's the first part. If you can answer the first part, you should be able to fill in this table as well. All right, but start with number 1 for both. How are each patterns changing? And what would step 5 look like? So table 2. What is the pattern in pattern 1? How are the dots changing each time? All right, guys, pay attention and take notes. So would you guys agree with that? It's pattern 1 adding 2 each time? Okay, so then write that next to pattern 1. Table 4. What would the number of dots be in step 5 then? For pattern 1 only. 3. Isn't it 3? Try again.
11.
Okay, why? Okay. That's fine, but then like, how is that gonna help them take the test? You can't just tell them the answer, you gotta tell them why. So how about we go to table 6? So it is going to be 11 in step 5 for pattern 1. Why is it 11, table 6?
Pattern 1 is just adding the time. And then you continue the pattern.
Okay, so you can continue the pattern. Why is the answer not 9?
Oh, 9 is the answer.
So 9 is the answer for step 4. So that's a good observation. If you thought the answer was 9, it's actually 11 for step 5. So that's why making a table could be helpful. So at step 0 class, how many dots were there in pattern 1?
1.
How many in step 2?
2.
How many in step 2? How many in step 3? And then in step 4, we're continuing the pattern would be 9. That's why in step 5 there's 11. Okay, so notice that skip. That's a great test question. If you're paying attention. Now, continuing the pattern might be tricky here because the jump from step 5 to step 10. I guess I could keep adding 2 until I get to step 10. But when it's adding each time, what type of pattern is that? Like with our math words. Linear is what I was looking for. Okay, when we add the same amount each time, that is a linear pattern. So what will the equation look like for our linear pattern? Okay, will it look like a straight line? What would the equation look like for any linear pattern? Okay, so why don't we make something an equation to make this easier for us? M would be slope. What is it changing by each time? The 2, and it's adding to a positive 2. X could be our step number. And then it's plus B, our y-intercept. What is our y-intercept? So then instead of adding 2 each time, which really isn't a bad method, this is what you gotta do to get the right answer. I could just replace X with 10 and work that out to get my output. What's 2 times 10? And 20 plus 1? Okay, good. Now that last box says n, and that's great because they use that a lot. They use n a lot for nth term. So like if they want you to find the 20th term, the 100th term, whatever, n can be any number. So what do you think they want in this box? Good. So an equation that'll help us with any value for n. So what would we put? 2n plus 1. All right, you can easily make it because we know that it's a linear function since it's adding the same amount each time. So there we go. So when it has that step n, it wants you to give an expression that'll help me find any value of n. Good question? All right, now is pattern 2, let me ask a specific table. Table 8, is pattern 2 linear? So in other words, in pattern 2, is it, stop talking. In pattern 2, is it adding the same amount each time?
No.
I'm just talking table 8. But no, it's not. Table 8, how many dots do I have in step 0? How many in step 1? Step 2? And step 3. Okay, so table 2, do you by chance know what it'll be in step 4? Not 5, but 4. Okay, you think 10? It won't be 10. Okay, 16. It's gonna be 16. Why? I'll show you in a second. Anyone know what it's gonna be in step 5? Okay, great. Now this pattern, it probably isn't easy to see initially what the pattern is, but you can definitely tell it's not linear. Because how do you go from 0 to 1? You could add 1. How can I go from 1 to 4? How can I go from 4 to 9? And what we end up seeing is a pattern in the difference, if that makes sense. Are we seeing a pattern now in the difference? Because what are we adding now to get to 16? 7. And what are we adding to the 16 to get 25? So that's a new pattern. Is that an exponential pattern?
Yes. No. Yes.
Exponential would be multiplying each time. So that means it is actually a quadratic pattern, but I'll tell you why in a second. Okay, so if you remember yesterday, linear was the first table. It was when we added each time. Exponential was when we multiplied each time. And this one was hard to figure out. But really, there was a pattern between the differences, right? So that's what kind of tips us off that there is a pattern, it's just harder to see. So if that pattern is harder to see compared to the one we've already done, odds are it might be the exponential pattern. Or not the exponential, the quadratic pattern. All right, but here's how you can know for sure. Can you see the pattern between the inputs and the outputs at all? So like pretend this middle column is in here. Just look at the step numbers and the outputs. Not necessarily, ignore pattern 1. Just look at the step number and the outputs. Tyson,
Yeah, put it in step number square.
the output is the step number squared. So what's 0 squared? What's 1 squared? 2 squared? 3 squared? 4 squared? 5 squared? And 10 squared? 100. So that's what step 10 is gonna be. What's my end step going to be? What can I plug in? What expression can I plug into to find any value of n? For this one, it's n squared. That's the pattern. We're taking the input and squaring it. Now let me show you the definition for quadratic real quick. Well, actually, let me have you write some stuff down first. So maybe star highlight what I'm about to tell you. Linear was what type of equation? Good, it's y equals mx plus b, and you can recognize it if it is adding the same number each time. Exponential, you guys remember the equation for exponential? AB to the x, actually. And then you can recognize that if it is doing what each time? Good, then you know the equation will be in that format. So multiplying the same number each time. Now quadratic, I'm going to tell you, I don't expect you to know, but now it looks like you know on my app. Quadratics, the most simple equation you can have for a quadratic function is going to be y equals x squared. So if it has an x squared in it and no higher exponent than that on an x, then it's a quadratic function. And you'll know that if it's not adding or multiplying. Okay? Questions on that? All right. So really, there's like a pattern between the differences, but we'll see more examples. All right. So then next side, and we're actually going to use this table for the next side. We're going to plot the number of dots at each step number for each pattern. So like for pattern 1, how many dots were there at step 0? So then you'll put a dot at the 0, 1, because there was 1, remember? And it's going really straight from the table. I'm not making this up. 0, 1. How many dots were there at step 1? So then you're gonna plot at 1, 3 to be about there. Can you guys answer the rest? Okay, try that. Pattern 2, you're graphing for pattern 2. So at step 0 for that one, it was 0 dot. Step 1, there was 1 dot, and so forth. See what it looks like. So if you graph them correctly, it should look like that. So this one, based on the graph shape, is what type of function? Linear, and that matches because we were adding 2 each time, so I should have a straight line. This one, it could look exponential, but what is it really? Quadratic. You can, in this one, only see like half of the U shape because we didn't have like any x values to the left of the 0. So like if we did that, plugged it into this equation, what's -1 squared? Remember, exponents tell you to multiply the base by itself. So what's -1 times -1? +1. You should never be able to square something and get a negative, by the way. Make sure if you're using a calculator that you put the number in parentheses.
4 squared.
What's -2 squared? So if I were plotting these, it would look something like this. And then you'd be able to see like the U shape. Probably a little bit more spread out, but. Yeah, so like here would be -1, +1, -2, +4, and then you'd start to see the U shape. So questions about that? Okay, scrolling down then. This will be like the last one of the day, and then you'll have time to practice. I could just give you the quiz. Again, we have the time to. But again, if I give you time to practice and you use the time to practice, then I'll keep giving you time to practice. If you don't, then I know like meaningless and you should just do it at home. All right, but this first, to make sure you understand. So here is a pattern of squares. Figure out within your groups, is it growing linearly? Is it growing exponentially? Or neither? Figure that out within your group. There's a table so you can organize your thoughts if you need to. We'll go over this in 3 minutes. Stop talking. So raise your hand if you think this is a linear function. Raise your hand if you think this is an exponential function. Okay, raise your hand if you think it's neither. $15-ish, give or take. All right. So let's see. Is this pattern adding each time the same amount?
No.
So then it cannot be linear. Glad no one picked that in this class, at least. Others people did. But it's not adding the same amount each time, so it's not linear. Is it multiplying the same amount each time? So then it's not exponential. So definitely it's neither then. Is it quadratic?
Yeah.
All right, so let's see. How many dots in step 1? How many in step 2? How many in step 3? 11, right? Is that what you said? Now, we probably should have done this first, but clearly it's not adding 3 each time. That's one way you can get to 6, but it doesn't continue. Clearly it's not multiplying by 2 each time. That's another way you can get to 6, but that's not how 6 goes to 11. So then just try to find the difference. So I could add 3 here, add 5 here. What do you think I'll add next? 7. So there's like a pattern within the pattern. 11 plus 7 is 18. What would I add next? 18 plus 9 is. All right, now that doesn't really help you when it jumps from 5 to 10 for the step. Does anyone know what it is doing? Or like the other pattern between like the inputs and the outputs? But between the inputs and outputs now though. Maybe anything you know, or is it something else? Okay, don't tell me. Adding 2 to what? Okay, so let's see. What do quadratics have to have? They have to have at a bare minimum an x squared. So if I do 1 squared, what's 1 squared? And how can I go from 1 to a 3? And that's what's going on in this pattern, isn't it? Like between these numbers. Let's see if it continues. 2 squared, what's that? And it's 4 plus 2, what it says in the table? So that's what they're doing, it looks like. What's 3 squared? 9, and then plus 2, is that 11? So if I had to make this an expression, what would the expression be?
N to the second.
Good, just like that. It's whatever the step is squared plus 2. So then if you plug this in, what's 10 squared? And then 100 plus 2 is, what's 12 squared? Plus 2 is, so yes, it is quadratic because in the expression, you have something being squared. So again, if it's not linear, exponential is probably quadratic, but that's how you know it's different. So questions, comments, concerns? Okay, work on your practice. I'll leave you a little to-do list because I really need you to focus on units. Alright, but remember, what are we putting on tomorrow? 6.1 and 6.2. Probably prioritize those, although these are also due, they're actually past due. But only work on stuff from unit 6 from now on, otherwise.